So Friday, quick review. We wound up our pathogen unit, our pathogen chapter by exploring bacteria a little bit, which mostly don't have to do with disease. Mostly bacteria, the vast majority of bacteria are not disease causing. We classified them by shape, by grouping, and by cell walls and movement. We said that they live everywhere, literally everywhere, and that they have pretty important jobs, like eliminating dead things and recycling their nutrients, like making life on Earth possible by fixing nitrogen into proteins and DNA and RNA, and being food for stuff. But and also just on the sort of immediate human front, they are most of you. In other words, there's more bacterial cells, 10 times more bacterial cells in you than there are your cells, which is kind of creepy. But of course, some of them make you sick, and we talked about how they do that. Now, shifting gears into chapter 35, into how you deal with that, how you fight off the stuff trying to infect you. Because it turns out you're really good at it. Like, your immune system is ridiculous in terms of being better than anything usually that a doctor can do for you. Like, you know, when you get a virus, the doctor says, drink lots of water and go home and sleep, and you'll be better in a couple of days. That's because you're going to win, right? Your immune system is this elite commando squad of cells in your body prepared for pretty much anything. We're going to talk about what we call non-specific defenses and specific defenses. So non-specific simply means that they don't key in on just one kind of bad guy. They're there to kill whatever's bad. Or keep whatever's bad from infecting you. What do you want to call the first line of defense against infection? What do you think the very front line is? I don't mean like metaphors. I mean like what's the thing that keeps you from getting sick first and foremost? Not yet. You're right, those are there, and that's behind those. Skin? But in front of that, yeah, skin. Skin, that's it. Yeah, skin turns out to be pretty crazy awesome defensively. Because remember, I think we talked about this, that your skin isn't just like live cells, right? Your skin cells are programmed to die. Like 4 or 5 layers deep of just dead skin cells that are designed to fit together overlappingly, so they're totally watertight, airtight, germ-proof, really. Right? It's a major barrier. Beatles or Joe Cocker? Correct. There's that problem, though, with your skin. What problem does your skin have? Do you remember the brain teaser? There's an enclosure with 11 doors. When one is open, yeah, your skin has the doors, right? It has to. You got to see and sense, you know, eat and hear and go to the bathroom. It's a bummer, because like it turns what would be like a near perfect suit of armor into like not so much. So we need to guard those openings. Your skin makes stuff too, right? Your skin makes sweat. Your eyes make tears. Your nose and throat make mucus. And that's part of your defenses of those openings. Because all those fluids contain an enzyme called lysozyme, which is very good at busting open bacteria. So that's nice. But then specifically, all your openings, or most of your openings, are guarded by a pair of defenses called cilia, which we talked about before in chapter 7. That's these guys, as opposed to flagella, right? This is cilia. The cilia and mucus which somebody mentioned before. Basically a germ trap. The germs stick to the mucus. Anybody got some of this going on right now? Give us a good cough. Give us a good. Yeah, that's it. So basically, the cilia is doing that for him. The cilia is constantly doing this way, like waving that mucus up and out, which is why you cough stuff up when you're overproducing mucus. But it's happening all the time. So basically, germs get trapped, then they get moved by the cilia up and out. Does that make sense? There you go. So, skin and openings. Now, your second line of non-specific defenses. If something gets in, if a bad guy gets past the skin and gets past the defenses at the opening, that's when you start to notice that there's a problem. You've probably noticed this mostly when you've had an infected cut, right? There's a break in the skin. That's a way that bad guys can get in. And at a certain point, you've learned from your parents or whoever that there's ways to know, that cut is probably infected. What are the signs? It hurts. That might be sign number one. You actually, like, instead of feeling better, it's feeling worse. It's starting to ache a little bit, maybe throb a little bit. It swells up, absolutely. Yeah, you start to see the yellow stuff. That's definitely a big clue. It itches. Sometimes it feels hot. Yeah, it's starting to kind of seep a little bit, and the scab is becoming kind of secondary. Good. So what you're talking about, all these things you're saying, are part of what we call the inflammatory response. We tend to think of stuff like this as, this is what the bad guys are doing to me. But really, most of what's happening here is you doing it to the bad guys. You are doing this stuff so that the bad guys don't do as well. First thing is blood vessels enlarge. Basically, that's your body's way of getting more blood to the affected area. You're going to see some effects from that. That would be the swelling, right? More blood means more volume, right? It's going to hurt. It's going to push on some nerves and stuff. It's going to turn a little reddish at first around the edges. What's happening as you get more blood to the area is that, and this is the first white blood cell type that we've seen, you're sending in basically the Marines. They're called phagocytes, and they are special white blood cells that are really, really good at, you remember this? Remember this? Remember how some cells can change the shape of their cell membranes to engulf stuff? So think of phagocytes as like that on steroids, like that times a million. They can basically throw loops of their cell membrane out and almost like lasso bad guys and pull them in and swallow them like 10 at a time. Like they're crazy good at eating stuff, okay? That's what phagocytes do. They engulf them until basically they're full of viruses or bacteria or whatever it is. And then they have, I think we've mentioned this, they have this big overdeveloped lysosome. Remember the sac that's got like nasty chemicals in it? They just pop that lysosome and they self-destruct, killing themselves and all the bad guys inside. Yeah, sometimes actually called suicide sacs, right? That's what they do. They kind of self-destruct, kill all the bad guys that they've engulfed. And so when you see that pus starting to flow, sorry, I know, gross. What you're seeing is a bunch of dead bad guys and dead phagocytes. That's what's leaking out of there. That's like the evidence that there's a battle going, right? So that's one thing. Also, you're going to see elevated temperature, which might even extend to your overall body temperature. I mean, the area of the infection, if we're talking about a cut here, is going to be hot. But your overall temperature might even go up. And again, we think of that as something that bad guy's doing to you, but really what's happening is your body knows that elevating its temperature is going to slow the bad guys down. And double benefit, white blood cells are built to work just a little bit faster at a higher temperature. So it slows down the bad guys, speeds up the good guys. It's a pretty good argument for, and I'm the one that this argument needs to convince, because man, I hate having a fever. I feel awful when I have a fever, and all I want to do is pop ibuprofen because it works to lower my temperature and make me feel better, but not necessarily the best thing for me, right? Because that elevated temperature can help me fight, as long as it's not like dangerously high. Probably I ought to let that fever run for a while and let it slow the bad guys down and speed my good guys up. A lot of times I don't, because I hate a fever. Because yeah, it makes you feel like crap. Final non-specific defense is called interferons. Interferons are chemicals that your regular cells make when viruses invade. They are antiviral proteins, not specific ones, but just kind of general antivirals. They're called interferons because they literally interfere with the virus life cycle. They stop it at certain points in its reproductive cycle, and interferons also serve to warn other cells and help them produce defenses as well. So that is all you need to know about non-specific defenses. It's the skin and the defenses it has, including lysozyme and the openings being guarded by stuff. And then it's inflammatory response, fever, and interferons, including the first white blood cell we've met, which is the phagocyte. I want to just start specific defenses so you can meet the phagocyte's big brother, sort of the ultimate powered up beast mode phagocyte. Which is called the macrophage. Okay, the macrophage is the start of a sort of a chain of events that is going to make it so that you absolutely beat whatever is invading it. So this is the specific defenses, and we're going to start with the macrophage. We'll end with the macrophage today as well. I'm going to see if my animation works. I really want it to. Oh, this is so cool. So we're going to go straight science fiction here. I mean, this thing looks right out of the movie, right? Okay, ready? I don't know if there's sound or not. Okay. So all these little green capsules are bacteria. just getting swallowed like crazy. It's just an ad for that animation company, but that's fine. Just wanted you to see it. So what's happening here, and there's a smaller version, is that this is basically a special enlarged phagocyte that is the key to the whole specific defense system. We're calling it a macrophage. It's also called an antigen-presenting cell. Do you remember talking about the stuff in the cell membrane, the 3 kinds of proteins? You remember what they were? I promise it's the last thing. Can you dig up the 3 kinds of cell membrane proteins? Or just what they do? Just what they do. There was one, if you'll recall, that was a transport protein that let things in and out. Yeah? Okay, what else? A long time ago, Mr. Sandro. What else?
Does that have something to do with carrier?
No. Just kind of lets things through. And there was the kind that like has a little shaped hole in it, that a little dent in it, and something will bind. Channel protein was a transport protein. Yes, good. And then there was a kind called what? Ooh, that's the kind I'm looking for. Marker protein. Remember marker protein?
Yes.
The kind that identifies a cell as what it is to you? Well, here's the secret. Every kind of cell has marker proteins. Even viruses have marker proteins. So they're not just, they don't work just to identify your cells. Your immune system can use them to identify bad guys. And that is what okay, this is the worst metaphor, but you're gonna remember it, okay? The macrophage, you know like how sometimes in the movies there's a serial killer that like takes trophies, like parts of his victims and like wears them.
Yeah.
Okay. So that's a macrophage. Not kidding. What a macrophage does is takes the bad guys in, like you saw with those tentacle things, little loops of cytoplasm, and then it chops them up, and then it floats parts of them to its own cell membrane and wears them to help other cells that like basically dock with it. And then they're like, okay, I know what the bad guy looks like. Like that's how the macrophage does what it does. It's like the recognition system. It takes them in, kills them, chops them up, wears them, and then other cells come in, and that's how they recognize what they're supposed to go kill. Does that make sense? Whew, okay. So that is, and there's a lot more to specific defenses, but that's the part I wanted you to see today. Basically, pulls in bad guys, wears, and then, by the way, we don't call them marker proteins when they're on bad guys, we call them antigens. And so the next step is a cell you've probably heard of, the T cells. The T cells are going to come in and dock with the macrophage. And the macrophage is A, going to show them the antigen, but B, it's going to secrete a protein called interleukin-1 that is going to make them kind of turn on and activate and go do stuff. Questions? There's a lot to know, but you did good. Rest of the time, since I know you didn't work on them in the time I gave you Friday, and I bet you didn't work on them over the weekend, why don't you get out your chapter 35 guided reading, which is about this stuff, and work on that, remembering that it is due tomorrow. Yes. Real quick, leave your phone on the cart. Thank you.